Okay, so today we're going to look at the definition of the derivative. So in our previous lesson, we saw that we used the limit of the difference quotient, which is the limit of the slope of a secant line between 2 points as delta x or h approaches 0 to help us find the slope of a tangent line. And the slope of a tangent line is also called the slope of the curve, okay, at a point. And so we saw how it was necessary to use that form and that limits are tied to this. Now you're going to learn that the definition of the derivative, which derivatives and differentiation are big unit of calculus. The definition of derivative is that limit, okay? So as you see here, I just generalized that the slope, okay, whether it be the slope of the curve at a point or the slope of the tangent line at a point, is the limit of our difference quotient as delta x approaches 0. Okay, and the a values are our x value of our points. Let's say when x was 2. All right, so this is saying when this exists, when we have an answer for our slope of our curve, this limit is called the definition of the derivative of f at a. Again, a is some value for x. So not only can we state that it's the derivative, and you should be writing this down, but it's also f prime of x. It reads as f prime of x, not an f apostrophe x. And that's really it, okay? So this note here says, if f prime of x exists, then we say that f has the derivative or is differentiable at x. Okay, a function that is differentiable at every point in the domain is a differentiable function. Now, you may be thinking, well, one doesn't exist because we have so many numbers. It has to exist at one value. So you can't have where there's 2 answers for the slope of the curve, okay, or the slope of a tangent line. We can't have 2 tangent lines. In the case of that, you should have seen it is when you have an absolute value, this is poorly drawn out, equation. You have the slope of the tangent line here at this point and here. So this is a non-differential function when x is a as seen. All right? So that's an example of something that's non-differentiable. We're going to be talking about more different types of functions that are non-differentiable, but later. Because here, now that we know that the definition of the derivative is this limit problem, we got to do more with our limit problem. Okay, so it says apply the definition of the derivative, differentiate. Okay, that's another way of saying find the derivative of. So sometimes you'll be told to differentiate something, and sometimes you'll be told find the derivative of. It means the same thing. Okay, f of x equals x squared plus 3. Okay, so when you're applying the definition of derivative, it's what you just copied in the last slide. So we want the limit of our difference quotient, and that's where we're plugging in a or x plus delta x. Okay, you can leave it as the x plus delta x when you plug it into your function. Again, if you don't like writing the delta x, you can put an h there. And you're subtracting the function itself. And this is as delta x approaches 0. Okay. So, again, if you don't like delta x, you can use an h. So we're going to just simplify this. We're just finding a limit. like we've always found our limits. So we have x squared plus 2x delta x plus delta x squared plus 3 minus x squared minus 3 over delta x. So with these terms subtracting and becoming 0, and this term can divide by our delta x, we're left with, let me write this in here and continue that here, f prime of x to be the limit of 2x plus delta x as delta x approaches 0. And if you're simplifying it with h's, you get 2x plus h, okay, as your expression you're taking the limit of, and h approaches 0. So now we make our delta x our 0, and we're getting the expression 2x. So this is the variable slope. That's what we call our variable slope of our tangent line, okay? Or the variable slope of our curve. So now when you're asked to do a problem like the do now, when x is 1, you would plug in 1, and you get the answer of 2. When x is negative 1, you get negative 2. So the answer for the do now should go quick. 2 times 0 is 0, 2 times negative 2 is negative 4, 2 times 3 is 6, 2 times negative 3 is negative 6. So when you have the variable slope and you're asked like these different x values, you can just plug them in. You don't want to actually put them into the definition all the time. Okay, the answer for 8 was 20, 9 was negative 20, 10 was 40. So there is also an alternate definition of the derivative, okay? And this is where we do want to put in our value of x and we get a numerical slope. We can just leave it with x and a's. It's a little bit difficult, but it's possible. But this is our alternate definition. So notice that it doesn't say f prime of x. We're not leaving it general. We're being specific that there is a particular value for x that we want to have, okay? So let's go back to looking at our function here. And our first value in our homework, in our do now, homework, not yet, do now was x is 1. So that basically is saying a is 1. Okay, and if I apply the alternate definition, please write this down. You can stop the video, write it, and then come back to my work. You have something like this. So it's the limit of this expression as x approaches 1. If you plug in 1, you should still end up with 0 for 0. That's not how we find our limit. We should know by now how to find a limit. We're going to simplify this. So you can see here that we have x squared plus 3 minus 4. So this is a minus 1. And let me change color here. So f prime of 1 is the limit of x plus 1 times x minus 1, because that's the difference to perfect squares. And hopefully you can see how this cancels. So f prime of 1 is the limit of x plus 1 as x approaches 1. So f prime of 1 is 1 plus 1. F prime of 1 is 2, which we had already discussed. So what we found was called our numerical slope. Okay, it's the slope of our tangent line at x equals 1, or the slope of our curve at x equals 1. Okay, yes, you do need to know both forms. If you're reading this, just jot this down into your notebooks. Of the limit definitions, okay, for future problems, and you never know how it's going to be worded to you. A lot of times they are kind of sneaky with multiple choice questions. it's really asking for you to do derivative, and it's in this form or the other form. So you need to be really, really familiar to identify it, okay? The graph that I was going to draw, let me draw that now, is similar to what I was drawing yesterday, or the other lesson, I should say. And here is our value for A, and X is some point off, so this is P and this is Q, and there's our curve F. So it's essentially like the same thing as before, but instead of writing the distance as delta X, the distance is X minus A, and that's why that's the denominator here instead of change of X. And the numerator is f of x minus f of a, because that's how we're expressing our y values. So change of y over change of x is still essentially there. All right, so I think you have everything you need to know to work on your problem, so good luck.